Part 5, the domain of a function. Determining the domain and range from a graph. For this graph, we want to find the domain and range. So let's look at the domain first of all. The domain is all of the possible x values, so from left to right. Notice on the left we have an arrow, so the graph keeps going on the left. And on the right we also have an arrow, so the graph will keep going on the right forever in both directions. So our domain is all real numbers. Every possible x value can be used for this graph. In interval notation, we'll write it as negative infinity to infinity. In set builder notation, we could write the set of all x's such that x is an element of the real numbers. I believe the homework usually asks for the answer in interval notation, but either one is acceptable. The range we're going to look at the y value, so bottom to top. So the bottom part of the graph will be when y is 0. In fact, it looks like it probably never touches 0. My guess is that 0 is an asymptote. It's hard to tell for sure without the equation, just looking at the graph, but I'm going to guess it doesn't touch 0, so we'll use parentheses, and then goes up to 4. When y is 4, that's as high as the graph will go. So our range will go from 0 to 4. The next one, to find the domain and range here. Again, we want left to right for the domain. So the very left x value is -5, and that one is included because it's a solid dot. And then we go all the way to, it looks like, -3, where we have an open dot. So -3 is not included in the domain because there is no part of the graph where x is -3. And then after -3, the graph keeps going all the way down to -1 and jumps, but notice that -1 is included in the domain because there is a solid dot right here. So the domain goes all the way to 3. Parentheses on the 3 also, that's this dot right here, which is an open dot. So our domain goes from -5 to -3, including -5, not including -3. And then from -3 to 3, not including either of -3 or 3. The range would be the y value, so from the bottom to the top. So the very bottom y value looks like it's -2, and we go up to -1, and that's from the line right here where we go from -2 to -1. Then there's a break, and it starts again when y is 0, and goes up to where y is 4. But where y is 4, that's the dot right here, so parentheses, because that is an open dot, y is not included there. What about this one? Here we just have some points. So it's not a continuous function at all, just a bunch of points. So to write the domain and range here, for the domain, we're going to use curly brackets and then list all the x values in order. So we have -4, -3, -2, -1, 0, and 1. Those are our x values of all of these dots. And then the range, again, we'll use curly brackets and do the y values. So -1, 0, 1, 2, 3, and 4 are the y values that are included on this graph. What about if we have an equation? So finding the domain from an equation or a formula. The domain of a function is the set of all input values for which the function is defined. If I look at the first one, f of x equals 2x plus 3, 2x plus 3 is always defined. We can take any real number for x, multiply it by 2, and add 3, and we will still have a real number. So my domain would be any real number from -infinity to infinity. If I look at g of x, any real number will work here except for the one that makes me divide by 0. So I know that 2x plus 3 cannot be equal to 0 because then I would be dividing by 0, which is not allowed. So I'm going to solve that equation, and I get 2x cannot be -3. Divide by 2, and I get x cannot be -3/2. So how do I write that in interval notation? So -infinity to -3/2. X can be anything in the interval from -infinity to -3/2. And it can be anything bigger than -3/2 also. Just not -3/2 itself. -3/2 is the only number that makes g of x undefined. Now let's look at h of x. We have square root of 2x plus 3. Thinking about real numbers, the only numbers that we can take a square root of are non-negative numbers, or any even root. If it was a 4th root, a 6th root, we can only take an even root of non-negative numbers. So whatever's inside the square root has to be 0 or greater. So 2x plus 3 has to be greater than or equal to 0 to make the square root of 2x plus 3 be defined. If I solve this inequality, I get 2x is greater than negative 3. So x is greater than or equal to negative 3. So x is greater than or equal to negative 3/2. So to write that in interval notation, it can be equal to negative 3/2 or anything greater. Let's try these ones. So I have f of x equals 2 divided by x squared minus 4. I'm going to start by factoring my denominator. That can make it easier to see where my function is undefined. Whatever makes the denominator 0 is where our function is not defined. So our denominator is 0 when x is 2 or when x is negative 2. So those are the values that we need to exclude from the domain. And to do that in interval notation, we would write negative infinity to negative 2. And then everything between negative 2 and 2 is allowed. And then everything after 2 is allowed. So our three intervals here, infinity to negative 2, negative 2 to 2, and 2 to infinity. Just not 2 and negative 2. Let's look at the next one, g of x. Here our denominator is x squared plus 1. So we know that can't be 0. But x squared plus 1 will never be 0 for any real number, because if I put any real number in for x and square it, the smallest that could be is 0, and then I'm going to add 1. Another way would be to just try to solve this. So I get x squared cannot be negative 1. Take the square root, and I get x cannot be plus or minus the square root of negative 1. But the square root of negative 1 is not a real number. And when we're talking about domain, we're only talking about real numbers. So any real number works in this equation. We can substitute any real number for x and get something that is defined. Last one, h of x equals square root of x over x minus 1. So we know our denominator cannot be 0. So x minus 1 cannot be 0, which means x cannot be 1. And we also know whatever is inside a square root has to be greater than or equal to 0. So x has to be greater than or equal to 0, but x cannot be 1. So how do we write this in interval notation? Well, x can be anything from 0 to 1, including 0, and anything greater than 1. So anything greater than or equal to 0 except for 1 is part of our domain. For this example, the Science Club successfully launches their model rocket with the height h of the rocket given by this formula, h of t equals negative 0.002 t squared plus t, where h is measured in feet and t is the number of seconds following the launch of the rocket. So what is the domain of this function? Well, the very beginning of the launch would be 0 seconds, so we're going to start there, 0 seconds. Just in this equation itself, the domain would be all real numbers. But in this context, it doesn't make sense to go back in time, so our domain is starting at 0. And then our domain would end whenever the rocket hits the ground. So when this rocket goes, it's going to go up and then back down. Eventually it will hit the ground, and then the rocket would either stop or it would bounce. But this equation would no longer be applicable after the rocket hits the ground. So we don't know when the rocket hits the ground yet. We'll come back and we'll finish the domain in a minute. Let's answer the middle question. What is the height of the rocket at 100 seconds? So I need to find h of 100, which is negative 0.002 times 100 squared plus 100. And if I put that in my calculator, I get 80. So after 100 seconds, the rocket is 80 feet above the ground. For h of 300, so how high is the rocket at h of 300? I'm going to put in 300 for x, so I have negative 0.002 times 300 squared plus 300, and I get 120 feet. The last question, after how many seconds does the rocket hit the ground? So when does the rocket land? Well, I know however high the rocket is, it follows this equation right here. And when it lands, the height is 0. So I'm going to set that equation equal to 0 and solve that. So if I'm going to factor out a 2 or a t, then I get negative 0.002 t plus 1. And because it's equal 0, then I can set each factor equal to 0. So either t equals 0 or negative 0.002 t plus 1 equals 0. So 2t equals 0, that's where the rocket started, was on the ground at time 0. So that one doesn't give us any new information. but the other equation will. So if I subtract 1 from both sides, I get negative 0.002t equals negative 1. And then I need to divide both sides by negative 0.002. So negative 1 divided by 0.002. And I get 500 seconds. So the rocket hits the ground at 500 seconds. And that is what we can put in our domain. So this equation no longer works once the rocket hits the ground. Either the rocket will stick in the ground or it will bounce, but this equation will no longer be applicable.